with differentiations. Here I am discussing first principles. Sometimes this is called ab initio. So what it means is, we know that dy dx of sin x, and we're gonna prove it, or the proof of this is called the principle. It's called the first principles. The proof is quite simple. So let's write y equals sin x. Now if I'll increase the y a bit, delta y, then x increases by delta x. So delta y is sine of x plus delta x minus y, which is sine of x plus delta x minus sin x. Here I will use a formula sin a minus sin b, and actually you should remember this for formula for these discussions. Sin a plus sin b is 2 sin a plus b by 2 into cos a minus b by 2. Sin a minus sin b is 2 cos a plus b by 2 into sin a minus b by 2. Cos a plus cos b is 2 cos a plus b by 2 into cos a minus b by 2. Cos a minus cos b is minus 2 sin a plus b by 2 into sin a minus b by 2. This is easy to remember, that you can make out if both are sine, one is sine, one is cos. Both are sine, one is sine, one is cos. If both are cos, or both are sine. So when there is a minus, only thing is there is a minus here. And if this is minus, it begins with a cos. So this is sin a minus sin b. So this is 2 cos. This is your a, this is your b. So this is x plus delta x plus x by 2. You can give a bracket, or if you need, you do not have to give any bracket also, because this divisional sign plays the role of the bracket, into sin a minus b by 2. So it's x plus delta x minus x by 2. So this is 2 cos 2x plus delta x divided by 2 into sin delta x by 2. This is what delta y is. After that, I will just write delta y by delta x is 2 cos 2x plus delta x by 2 into sin delta x by 2 whole divided by delta x. And here I'll just write limit delta x tends to 0. This is actually written as dy by dx. Now what I'll do, I'll take the delta x, I'll separate the cos, 2 cos 2x plus delta x by 2. This delta x I will write sine of delta x by 2 divided by delta x. In fact, I missed somewhere that here also you should write limit delta x tends to 0. So this part I will write here limit delta x tends to 0. Now we'll have to learn a bit of limits in this. Only one formula is in fact enough, that limit x tends to 0 is limit x tends to 0, sin x by x is 1. So here what I had is delta x tends to 0. So there is a delta x by 2. What I'll do is I'll divide by a 2. That means I'm dividing actually both sides by 2. 0 by 2 is 0. So limit delta x by 2 tends to 0. And there is a delta x by 2. So I must have a quantity delta x by 2. So I'll multiply and divide by a 2. Now this much of quantity becomes, let me say, delta x by 2. You are taking as theta. So this is theta, this is theta, this is theta, and this becomes limit theta tends to 0 sin theta by theta, which is 1. So this part goes off as 1. You can make out that there is a 2 left over here, but I can easily cancel with this 2. And finally I will put the delta x value as 0. This is cos 2x plus 0 by 2. So that's equal to cos 2x by 2, and this is cos x. In all these discussions we do not have to worry for the cos quantity, because there is no formula for cos. We do not require any formula for cos, but only for sine and for tan. So limit x tends to 0, tan x by x is also 1, as it is sin x by x. So whenever there is a cos quantity, you can put directly the value delta x tends to 0 means delta x is equal to 0 finally. Try to understand finally. At the end only you should put, otherwise it's mathematically something what we shouldn't follow. Join me in the next discussion for some more discussions on first principles.